All right, so this is our full circuit. So as you see over here at the top is an instruction set, which is connected to our master controller right here. And this kind of controls the multiplexer right here, which controls 4 of these multiplexers going into these AND gates, which all control the clock of our scalar function, all 4 of these in parallel. And then the outputs of these scalar functions go into these adders, which all kind of add the outputs together, which will then go into this 32-bit accumulator into this neural transfer function. So we're going to start a simulation to see this works, and we're going to focus on a AND operation with both of our up and down counters. Represent our 1 and 1 represent the first 2 bits, 1 and 1 represent our up and down counters. And if we take a look inside of our scalar function right over here, you can see that our up counter has increased and our down counter is active as well. And this will also change these values every clock cycle. And then they will go down into this accumulator value down here at the bottom, which is displayed with these LEDs. And then up top is our scalar register bank, which holds all of our values. And then RI and RJ are also outputs. So right here over here is our control logic, which handles all of our arithmetic pretty much. And then if we take a look inside, you can see all of our ad hoc design circuits needed to create these selectors and whatnot. So right now, this is our master controller, which, as you see, uses fetch, decode, write, execute. And then there's these outputs that display which one is active, whether it's a vector, 32-bit accumulator, the fetch, decode, so forth. So we're going to run the simulation a little bit more, demonstrate some values. And right here, you see an output of 1. Now, if we change the instruction set to 32-bit accumulator, then this clock will activate, resulting in this value of 2 inside of that register accumulator. And then if we put our neuron transfer instruction, you can see the clock is activating neuron transfer function. And then this is our neuron transfer function. And you can see that we're trying to compare a value of OD9, which is 217. And then once that value is above that, will fire. So now we're gonna simulate this a little quicker to get some very good data and demonstrate this function firing, this neuron transfer function. And then we're letting that run for a little bit to build that up. And then we're gonna change these back to the accumulator instruction set to add that value. As you can see, that's FFFD in the accumulator. And then once we change it, the instruction set to the neuron transfer function clock to activate that, boom, you see an output of 1 after that neuron transfer function. And this is our circuit. Thank you.